Hello guys, welcome back. It's time for another Leetcode challenge. This time we are solving Leetcode number 980, unique paths number 3. This one is a hard problem. Let's take a look at the description and see what is this question about. The description says you are given an m times n integer array, it's called grid, where grid I and j could be 1 representing the starting square, that is exactly one starting square. 2 representing the ending square, where that is exactly one ending square. 0 representing empty squares we can walk over, or -1 representing obstacles that we cannot walk over. So the question is all about returning the number of 4 directional walks from starting square to the ending square that walk over every non-obstacle square exactly once. Okay, so a few good info on this question here. So they are giving us a matrix, basically a grid. The values that we can find inside this grid are 1, which represents the starting square. As the example here, example 1, there is a robot in the first square. Number 2 will be the end, where we should finish our journey. 0 represents an empty square where we can walk. And -1 represents obstacles, so we cannot walk over them. So if we hit an obstacle, we have to go back and take another route, as represented by this brick wall here. Okay, pretty simple. Let's just go to our middle boards here, and I'm gonna show you guys how the algorithm works. So that's our amazing maze. Yes, pun intended. This is our grid, just like the one we saw on Leetcode. And we have our robot here, or whatever mechanism we can think about that's gonna walk the grid for us. In this case, I have a robot that's gonna do the work for me because I'm lazy. And this is our grid. So just a quick one here. So the violet here, or the light blue, is a row and a column, coordinates, and the black value is the cell value. So we have number 1 here. This is where we should start, but as we don't know where to start because they don't give us that in the description, so we have to go through the whole grid and find the exactly point where we should start, which in this case is 0, 0. That's the first row and first column. We have to count how many slots we have that are not blocks, so they're not brick walls. So I have to count everything, and then this way we would know once we reach this cell here, which is true, we have walked over all of the other cells. When we get here, we know that we found the solution because we've reached the end, and the number of cells remaining is only 1, because that is exactly the difference of good rows versus blocked rows we found out. So just to give a quick illustration here, the first path we can go is this one. We can go 0, 0, 0, 1 to 0, 2 to 0, 3. Then we go to 1, 3. Then again, we can try going here, but this one is not allowed. Then we have to simply go back. And then we can go left. So 0, so good. Then go here, we go here, we go here, and then we go here, and that's it. That's the end, because we just found a cell which value is 2, and we have walked for the whole grid, and there is only one missing, which is the one we cannot go, because that's a roadblock here. So this was one path we made, but that's not the only path we could go. So we have to backtrack. We're gonna undo the path we did, and then we go back to where we started. So we did this path here. Now we're gonna do our second path, which is simply going in this direction here. Yeah, let me just do the arrows. That's gonna be easier. So then we go there, then we go there again, then we come here. We can try coming here, but that's not allowed. We have to go back. Then I come here, and then we go there. So that's basically the second path. We go. Then it's gonna backtrack again, and just another pass. We are doing this path here, and then we find the solution, because we have walked on the whole matrix again, and there is only one cell that we skipped, because that's a blocking, so we cannot go there. And yeah, the expected result is we have 2, because this was the first path I took. 0, 0, 0, 1, 0, 2, 0, 3, 1, 3. Yeah, you guys can just double check that was the first. Let me remove again. Yeah, that's my robot. So this was the first path I took. 0, 0, 0, 1, 0, 2, 0, 3, 1, 3, 1, 2, 1, 1, 1, 0, 2, 0, 2, 1, and 2, 2. And the second path is this one. This is basically what we did, and that's how we got to this result here. So again, as I said here, we have to keep going and then backtrack to try another route. That's exactly what we're gonna do. We're going to use a backtracking algorithm here, similar to the last question. Okay. Again, I'm gonna create an instance variable here. It's gonna be a grid. I'm gonna create another one, which is the total, because I have to find out the total unique paths we can walk through the matrix until we reach the end. Yeah, and also need a Boolean array. That's gonna be our visited array, because we need to mark all the paths while we are going through the path. We have to mark these elements so we don't walk over them again and again and again during that path. Okay, easy. So again, grid, receive grid. My visited, for that I can say int n equals to grid.length, int m equals grid0.length. So that's number of rows and number of columns. So visited receives new Boolean n m. That must match the matrix size and number of elements, because we have to mark those elements. Again, I need to create a start row and a start column. Once again, we have to find out where we start, because the question doesn't tell us, and they only say there is one cell that is 1, which represents the start. So, and as we don't know where it is, we have to go through the whole matrix. So again, let's walk the matrix and looking for a column equals to 0. Oh yeah, I can use m and n here. C++. So the first thing here is I need to find out where to start. So if grid RC equals to 1, then this is the place where I should start. So start row equals to R, start column equals to C. I also have to count all cells that are greater than or equals to 0, because I need to count all the steps here. And yeah, the last one, that's gonna be my final step. Okay, so if grid RC greater than or equals to 0, I'll need another variable here, steps, and steps, I simply increment steps. That is the number of available rows I have to go through. Last thing here is to return the total, which is my instance variable here. And then I'm gonna write my magic backtracking function, which I'm gonna pass the starting row, starting column, and the number of steps. And then here, now I'm gonna write my function backtracking. Again, it's gonna receive a row, a column, and the number of steps. So this is the magic function that will solve our problem. First check here is if row and column, if they are outside boundaries, if they're out of boundaries, which is simply asking if r less than 0 or r greater than or equals to grid.length. I could have passed n and m here, but let's just go. Actually, int n private int m. That's gonna make again our lives easier. And or column less than 0 or column greater than or equals to m. So which means if we somehow fall outside the bounds of our matrix, we should not do anything. We should backtrack and simply return. Okay, or if we have visited that cell, or that cell is a roadblock, which is -1, so, or an obstacle. What we have to do is simply return. We don't have to do anything because that cell, this specific cell, is out of bounds. We just return. If not, if it's a valid cell, we then check if we reached the final destination, which is grid row and co is equals to 2. and number of remaining steps is only 1. If so, we increment our total, which is the total number of paths we could find, and we return. Okay, now inside our that's gonna be now the meat of our backtracking solution. First thing is to mark that cell as visited, because just, for example, whenever we, let me backtrack here. Once we land here in our algorithm here, so it's not going to be out of bounds. That's going to be the first time we enter inside this function. That's not going to be the end. We simply mark that that cell as visited. Yes, that was visited. I was there. We decrement the total steps, because we have here one less step to go through the matrix. And then we can use recursion or our backtracking algorithm to keep walking. We have to go on the four directions. We should go left, right, up, and down. So that's what we're gonna do here. So row +1, column, backtracking row -1. This one goes down, this one goes up, and backtracking row, this one goes to the right, and this one goes to the left. Okay, and again, once we explore that path, we have to mark again visited as false, because we are probably going to try another path, just like as I showed you guys here. Let me delete this one. So yeah, first path is this one. Just take this red mark as visited. So as I'm walking through the matrix, I'm marking those cells as visited. This is one path, but then I have to backtrack to try another path. So I have to unmark them and then go to the next path to solve the solution using the second path. That's why we should mark visited and then unmark visited once we backtrack. Okay, yeah, I think that's it. I think we are good. I hope I have not missed anything here. So let's try running our code. Okay, backtracking around C. Yes, I totally forgot to pass these steps. Let me copy and paste. And try it again. Oh, visited. Cannot find the symbol. Visited. Visited. Oh, visited. Okay. Run again. Oh, finally it passed. Okay. Yeah, and now let's try submitting. Yes, it works pretty well and pretty fine. So this is the way to solve this problem using backtracking. There are other optimizations, for example, that we could do. We could, for example, try doing this, exploring creating the algorithm to explore the 4 ways before, for example, and we could check if we are out of bounds before calling the backtracking algorithm. But that's really a minor fix. We could also, instead of using visited here, let me delete visited. We can use the flood fill algorithm and operate straight on the grid. So grid R C. Let's just save the value. Then grid RC will receive, well, it can be any arbitrary value. Let's say -1 because that's a roadblock. And then grid RC, let's receive the temporary value here, and we can simply kill visited. And then we can use flood fill and not having the extra space dedicated for the visited array, which works fine again as well, but this time using less space. Okay, cool. I hope you guys have enjoyed this video. Please leave your like. Also click on the subscribe button, as once again that helps us a lot promoting the channel. And also, if you have any questions or suggestions, give them in the description below. Okay, I'll see you guys in the next video.